Hello, we will now talk about Chapter 8, Section 2, which deals with making a confidence interval with a proportion, with one proportion. This is one proportion Z interval, as we're going to call it. So let's look at this context. So this says, an archaeologist wishes to estimate the proportion of artifacts at a site that have a metal in them. There are thousands of artifacts at the site. She takes a random sample of 120 artifacts and finds that 38 of them have metal in them. She wishes to create a 95% confidence interval. So what we have going on here, like we talked about last chapter, is we have a parameter, a P, that we want to estimate, a proportion. And so in this case, we don't know what P is. P is the proportion of all the artifacts at the site that have metal in them. And we don't know. In the last chapter, they would sort of tell us that, and we kind of established the theory that we're going to use in this chapter. But we are going to estimate that with a p hat, with a sample proportion. And so the terminology of last chapter is still comes into play, like the population here could be asked about that. And the population is all of the artifacts at this site, and the parameter is the proportion that have metal in them, which we don't know. The sample is the 120 selected artifacts that we are actually going to study. And then the statistic is 38 out of 120. So our point estimate, or we just called it an estimate last chapter, but our point estimate is p hat. And so p hat is, in this case, 38 out of 120. And that, in fact, is equal to 0.316 repeating. So that is our point estimate right there. That is our point estimate. And so, they can give you this either as, the number of successes, so to speak, over the total number, or they could just give you the proportion. They could just say the sample size is 120 and 31.6 repeating percent of them, have metal in them. So a couple different ways to do that. All right, standard error. The standard error, and the formula for this is on your formula sheet. So let me pull that out. It's on page 2 of your formula sheet, right next to the stuff we did for with chapter 7. So sampling distributions and inferential statistics, which is what you're doing now for proportions. And notice what it says here, standard error of a sample statistic. And there it is. So that is the one for section 8.2. And this is going to be the deal for section 8.3 there. And so notice how similar it is to this. And so notice the difference though. We're using p hats in place of the p's because we don't know what p is. In chapter 7, we knew what p was, but here we don't, so we have to use p hats in its place. So since we're using estimates here, we call it error, standard error, not standard deviation. So, but it's a very similar concept. It is the average amount that our estimates are going to vary from the mean. But anyway, so there's our formula for it right there on your formula sheet. And so in this case, that is going to be the square root of, and so that's 0.316 repeating times 1 minus that, and 1 minus that would be 0.683 repeating, and then divided by our sample size of 120. That, in fact, is equal to approximately 0.04246. So that's our standard error right there. So that could certainly be asked of you, as could all of this, obviously. And then the margin of error. So the formula for our margin of error is going to be this. And so it is this. It's going to be Z star, we'll talk about that, times your standard error, times the square root of p hat times 1 minus p hat over n. So Z star is what is known as a critical value. It is the number of standard errors that are intervals going to the left and to the right. It is determined by your confidence level. So your confidence level is going to determine your Z star. So in this case, it's 95% confident. So there's a couple of different ways to find the Z star that goes with 95%, and I'll show you both. So the easiest way possibly is just to go in your formula sheet to table B, one of your formulas, and you're going to go down to the bottom. It has the confidence levels here, has the most common confidence levels. And so ours is 95%. The number that's right above that is the Z star. Okay, so it says infinity out here, and we'll talk more about why it says infinity there next chapter, or actually a couple chapters after this. But these are the Z star values, this bottom row in this table B. So the Z star that goes with 95% is 1.960. And so that's what we'll put here, 1.960. 1.96 times, and we, of course, we just found that that's your standard error. So we just found that times 0.04246. And that, as it turns out, is approximately equal to 0.08323. That is the margin of error. That is the amount that the interval goes to the left and to the right from its center. Now, I want to quickly show you how to find Z-star with your calculator. So, but you can always use your table like this, but with a 95% confidence interval, we could use the concept of a sampling distribution to find this Z-star. And so we're going to use what is known as the standard normal curve with a mean of 0 and standard deviation of 1 to find our Z-star. With a 95% confidence interval, it in essence sort of means that our interval is going to take up 95% of the distribution. The Z-star is the value that's going to be right here. And so what we'll do is we can use inverse norm, and use the area that's to the left of that. Well, if 95% is inside the interval, that means 5% is outside the interval. That means 2.5% on each tail. 2.5% on each tail. And so then you would say, what is the area to the left of this value? Well, you would add that total area. That's 97.5%. So we'll go 0.975, mean of 0, standard deviation of 1, and that'll give us a more exact version of our Z-star. And so we will go to inverse norm. Remember, it's above the vars button. So we go second distribution, which is vars, and go inverse norm, 0.975. Notice it automatically sets it to 0 and 1, by the way, the standard normal curve. And voila, there is the Z-star. It's approximately 1.96, and but that gives you a more exact version. But like I said, you can always use the table for that. All right, so there we go. So now here's the deal in regards to, we're going to create here's how you create a confidence interval. All right, so we're going to create a confidence interval for P, the portion of all the artifacts that have metal in them. Our estimate is 0.316 repeating. But what we're going to do is we are going to make an interval around it. And then we're going to say we're reasonably confident the population parameters in that interval. And so that's sort of the theory behind it. Whenever you make a confidence interval, you have to do the TAME acronym. Okay. And this is just something that different books kind of say different things in regards to this, but they all say you have to do, in essence, these 4 things. So not everybody, does this exact acronym. It's just what I made up. But what you've got to do is, whenever you make a confidence interval, you have to write a little mini essay. First of all, you have to say what you're doing. You have to state the type of inference that you're doing. And so for the rest of the year, you're going to be doing this TAME acronym or its relative, the TAME acronym. All right. The A is you must check your assumptions. You must verify your assumptions. In other words, are you getting good data? And are you properly drawing your conclusion and making your calculations? This is otherwise known as verifying your conditions. Most of the time it's worded that way, actually. All right, then the M of the TAME is you do your mechanics. In other words, you make the interval. You do your mechanics. And then lastly is you state your ending. Okay, you draw your conclusion in context. So every time you make a confidence interval for the rest of the year, you've got to do those. You got to do those 4 things. So let me show you how to do that with this in this particular case. So here's our estimate, 0.316 repeating, 0.316 repeating, and we're going to make an interval around that. And so we go, and so here we go. And so the name of the type of inference is a 1 proportion Z interval. Now there's the one later in the chapter in section 8.3 is a 2 proportion Z interval. That's what you have to, sometimes you'll see this worded like in a multiple choice situation, you may see this worded as a 1 sample Z interval for proportions. That's the same thing, but it's a simple thing to just say that. And it's pretty much listed on your calculator as well, which I'll show you that in a minute. So that's step 1. And if you do that, you got 1/4 of the problem right. All right. Step 2 is to what is known as verify your assumptions. And this is kind of the most time consuming part of it, really. Otherwise known as verifying your conditions. You must verify them. In other words, you don't just list them, you state whether or not you think they're true or not. So And they are going to spell out, let me just say this to you. In general, our conditions are going to spell out the acronym SIN. SIN. And so we're going to be sinning the rest of the year. Is it an SRS or is it random? Okay. Is it random? Have they collected their data randomly? Okay. Or have they, in an experiment, randomly assigned to treatments? All right. The I stands for independence. And what the aspect of independence that we're checking for is that our sample size cannot be more than 10% of our population size. Otherwise, we lose independence, and we're changing our population as we do our sampling. So so that is the second condition right there. Otherwise known as the 10% condition. And guess what N stands for? Yes, that's right, normality. We have to have normality to make our calculations in this chapter. And so normality occurs in this section is if N times P or N times P hat, because we don't know what P is in this chapter, N times P hat and N times 1 minus P hat are greater than or equal to 10. So those are the things we've got to verify. And so this is how we're going to say them. All right, so it says a random sample was taken, so random conditions met. You can't just say random, okay? You have to state a sentence as to whether or not it says it up here, okay? And if it says it up there, you would say it says random sample or SRS. All right, was taken, so random condition is met. There you go. That's the way you say. You have to say whether or not you think it's met, okay? All right, and so independence is met because little n is less than or equal to 0.1 times big N. In other words, our sample size is less than 10% of the population size. And it says up there that the sample size is 120 and that there's thousands in the population. So there we go. And then lastly, N times P hat and N times 1 minus P hat are greater than or equal to 10. This is in essence, N times P hat is in essence our number of successes. You know, it would be 38 out of 120. That's our P hat times 120, which is just 38. Okay, so that's our number of successes. That's in essence our number of failures, and they're both greater than 10. You don't have to show the letters, you just have to show the numbers, okay? And say that they're greater than or equal to 10, and then say thus normality is met. That's the easiest way to do it. Now, truthfully, if you were stating it more completely, you would say thus the sampling distribution is approximately normal, but it's just easier to say that. And so there you go. That's probably the most asked about part on the AP exam in regards to statistical inference. But that is sinning. And those are the three things you have to do when you're verifying your assumption. Was it random? Do we have independence? And is normality met? Now let's make our interval. So to make our interval, and so our little formula for that. So let's look at our formula sheet. So here is the mechanics. And let me show you on our formula sheet, we have the generic formula for a confidence interval. There it is. It's on the bottom of page 1. Every confidence interval is in essence a statistic plus or minus a critical value times the standard error. And this critical value times standard error, as we discussed before, that's your margin of error. Well, our statistic in this case is P hat. So this is in essence P hat plus or minus our Z star, which once again, we can get that off of our table, off table B, at the bottom of table B, or we could use inverse norm. And then our standard error is the square root of P hat times 1 minus P hat over N. And so I just plug those values in. Okay, of course, I found them at the top of the page anyway. And then you simplified them down. So there's our margin of error. And so then, to state the interval, you would just go 0.316 repeating plus that, which is that. And then 0.316 repeating minus that, which is that. And there's our interval of values. Those are in essence the plausible values for P. Okay, those are the plausible values for P. And so values outside of that, anything above 3.9 repeating or anything below that are not plausible values. And so there you go. That's the mechanics. This is the only thing you in essence have to write down. And then lastly is the ending. The way you're going to do the ending is you are going to interpret the interval in context. And so in essence, this is what you're going to say. You're going to say, I'm 95% confident that this interval captures the parameter P, which is the proportion of all the artifacts of the site that have metals in them. All right, so it is important that you state it in context. But look, every time you do an ending with a confidence interval, you're always going to say, I'm 95% confident, or whatever your confidence level is, 99%, 90%, whatever, that this interval captures the parameter every time. And then you're going to define what the parameter is. So it's important that you define your parameter. Now, our book tells you to go ahead and define P at the top of the problem. But if you did that, then you would have to define it twice, because you always have to make sure and state your ending in context. But that's how you do it. All right. And never put P hat here, by the way. Always put P in this chapter. Okay. Because this, the sample value, it's always going to be in the exact middle of the interval. Okay. So it's all about that. So that's how you do it. That's how you make a confidence interval. And that's in essence, the main part of chapter 8, section 2. Now, let me show you the shortcut with your calculator to find the interval. All right. And, to show your work here, you can just write the interval and get full credit. You could just write that and get full credit. Of course, if you miss it, then you'll get no partial credit. But, so I tend to like to show my work here, but anyway, but be careful, because if you make an error here, they'll have to dock you for it. But this is how you do this with your calculator. So what we're going to do is, to make a confidence interval, we're going to go to our tests menu. So this is a new menu for us. So we're going to go to stat and then go to tests. Even though this isn't a test, this is an interval. And so for this chapter, for this section, we're going to scroll all the way down to option A. There it is, a one proportion Z interval. Okay, and so by the way, option B is what section 8.3 is going to be, but section 8.2, one proportion Z interval. And there's the name. If you forget the type of inference up here, just look on your calculator list. There it is, option A. That is sort of the name of it. Okay, so we hit enter on that. And so what we'll enter in is X, which in X in this case is our number of successes, which is 38. Then we'll enter in our sample size, 120. And so then we'll enter our confidence level, 0.95. And boom, we got ourselves the interval. And so there's the interval. And so there you go. And it gives us the point estimate there. And so we could find the margin of error just by subtracting, that minus that. And that'll be the margin of error is how far the interval goes out from the middle. So and so there you go. And if you divided that by, your critical value, give you your standard error. But anyway, so that's how you use your calculator to do that. So and so there we go. And so that's the main part of that's the heart of section 8.2. Now, important concepts that you need to be aware of, as we discussed in section 8.1, interpreting the confidence level. Now, what we just did on the other side here, that's what is known as interpreting the confidence interval. And you have to do that every time you make an interval. Have to do that. All right. But interpreting the confidence level means this, and we discussed this in section 1. It means that we are going to say, interpreting the confidence level, if we made many intervals using the same procedure, all right, 95% of them would capture P, the proportion of all the artifacts at the site that have metal. Okay. So that is properly interpreting the confidence level in context. Notice once again, I stated the context and I clearly stated P, not P hat. Okay. So that's what in other words, that's what 95% confidence means. When we say we're 95% confident, we're saying, hey, we're using a procedure that is going to be successful 95% of the time. It's on if we did this a large number of times, 95% of the intervals would actually capture P. And the next question, it says this: a scientist claims that 45% of the artifacts have metal in them. Comment on this claim. Well, notice in the interval, the plausible values are between 23.34% and 39.99%. 45% is not in the interval, so it's not a plausible value. And so that is in essence what we are going to say. 0.5 or 45% is not in the interval, so it's not a plausible value for P. all right, which is the proportion of all the artifacts at the site that have metal. So the scientist's claim is probably wrong. Okay, so make sure to address the question that's being asked. So that's a very frequently asked thing about confidence intervals. Another important, very popular problem is this. All right, Marcos wishes to create a 95% confidence interval for the proportion of students in his school system that are failing a class. He wants the margin of error to be at most 3 percentage points. How should he select a sample size? So now we're finally to the point where how do you decide what sample size you're going to use? Well, it depends on how wide you want your interval to be. And with proportions, very typically 3 percentage points is sort of a popular thing. And so here's our formula for margin of error, as we discussed. All right, it's Z star times the square root of P times 1 minus P over N. Now, of course, previously in this section, we used P hat here, okay? But guess what? We got no P hat to work with. So we're going to use what is known as P star. P star is just a fill-in that we have for the estimate of P. And in general, we're going to go with 0.5, all right, 50%. We're going to go with 50%. If we have no other one. A lot of times in the problem, they'll say, use 40% or as an estimate for P, or it'll say use 1%, okay? But this is the one, the 50% is actually the one that's going to create the widest interval. So it will make sure that we are getting a sample size that is big enough. And so what we will do for our margin of error, we'll just plug in 3 percentage points, which is 0.03. All right, and then we'll find our Z star off of our table, 1.96. And then we're using 0.5 for a piece for our P. So that's that. And so N is what we're trying to find. And so from this point, we're just using our algebra skills, to solve for N. So we divide both sides by 1.96 to get that. We square both sides to get that. That's 2.34 times 10 to the negative fourth. And so we square both sides. And so then we get N out, multiply both sides by N, and divide by that number to get that. Okay, so if you're struggling with any of this algebra, please let me know. We can chat about it. And so then we just divide those two things and we get this. And it's important always, in this situation, when you're picking a sample size, always round up. Always round up. And that ensures when you do your sample and you make your interval that your margin of error will actually be a little bit less than 3 percentage points. A little bit less than 0.03, which is what we want. Also, by the way, picking 0.5 to be in here also ensures that when we make our interval, that our sample size is big enough to where the margin of error will actually be a little bit less than that. So, and so there you go. And that's a popular sample size with proportions, a little over 1,000 people, because it generates that. And so a lot of national polling, you'll see them around 1 to 2,000. So their margin of error would be like 2 or 3 percentage points. All right. And so the in general rule of thumb, though, is this. All right. We talked about this in the first section. All right. What can make your margin of error, and thus your confidence interval, smaller? Like if you have this interval and it's too wide and you want it to be more precise, what should you do? One of two things. All right. You're either going to make a sample size larger, and it's the margin of error and the sample size are inversely related by the square root of the sample size. So if you need your sample size, if you need your margin of error to be half as big, this has got to go up by 4. Okay, the sample size get up by 4. If you need the margin of error to be a third as big, the sample size has to go up by a factor of 9. You got to multiply by 9. All right. The other thing you could do is change your confidence level, change your Z star, because you'll notice the bigger levels of confidence, right, have bigger Z stars. And so that's going to make a bigger interval. So there's a trade-off there. Like with 99% confidence, you get your Z star 2.576. But if you just have 90% confidence, your Z star is 1.645. And so that would mean your margin of error, would be bigger, but you have more confidence. Okay. Now, if you have a smaller interval, okay, it feels like you're being more precise, but you're less confident that it's actually in there. You're less confident. So there's certainly a trade-off there. The most popular thing is to increase your sample size. And so then, that's, really the main part of the chapter. So now let's look at this. So let's look at this situation. This has been asked before. It hasn't been asked much, but when you're asked to figure out a confidence level based on an interval, the confidence level being like, is it 95%, 99%, 98%, or what? In an SRS of 350 voters, 214 said that they favored a particular amendment. The confidence interval that was created was from 0.569 to 0.645. What was the level? In other words, what was the percentage was given to you? Okay, well, if we could figure out the Z star, we could figure out the percent that goes with it. So which of these Z stars go with it? And so, well, how could we figure out Z star? Well, we have the formula for margin of error. Okay, if we can find the margin of error, we have an estimate for P and N, we could figure out Z star, then we could figure out the confidence level. And so what I did here was, so to figure out the margin of error is one thing you can do, as we discussed last section, is you can subtract these two things and divide by 2. All right. So, and that will tell you your margin of error. So when you say that minus that divided by 2, so it's 0.0425. That is how far the interval is going to the left and right from the center. All right. So the P hat is always going to be in the middle of the interval. Okay. So the middle of this interval is 0.6115. And then you can subtract that minus that, 0.654 minus that, to give you your margin of error. That'd be the other way of doing it. So that's our margin of error. And that's how given the interval, that's how you find the margin of error. Subtract these and divide by 2. And then we enter it in that formula. Z star is what we're trying to find. And then we put our P hat in for P here, there, and then it says the sample size was 350. And so then we just simplify this down. We solve for Z star to be that. And then we would look on our table and we would say, well, 1.63, that's pretty close to that. And so it's about 90%. And so when this has been in the exam before, that's what they pretty well accepted. Okay, now is about 90%. The other thing you could do is you can, in essence, use normal CDF. And so this is the standard normal curve, mean of 0, standard deviation of 1, to find a more exact value. Is Z star is how far out on the standard normal curve that we're going. And we need to know the percent that is in there, the percent that is between our Z star and our minus Z star. And so we could do normal CDF in our calculator, mean of 0, standard deviation of 1. And so when we do that, we get, we get this, we get about 89.72%, 89.72% right there. And so, but 90% is close enough. That is really a technical sort of thing. And like I said, this problem has only been on the exam a couple of times in the 23 years of the exam. But that's it. That is section 8.2. And I wish you much luck. I thank you watching for the video. Please send me any questions you have and do your best on the bookwork. And I hope you have a great day.